that these things work is that they give you definitions and things of how to show something happens. And then the following day they say, hey, if that happens, then it works backwards. So hence why it says, we'll work backwards. I thought it was clever. Oh. Magic. I just pressed a couple of buttons. Huh? You didn't know you can do stuff with this? Flip it upside down. Actually, that's easier to read upside down backwards. If you have, here, you always have your phone in your pocket. Look at it, it's behind you, you should be able to read it. Okay. Where's your glasses? Anyway, what I want to do here is I made this chart sheet. It's been a staple in geometry for like ever. What I want you guys to do real quick is to kind of go through this. So dry. What I want you guys to do real quick is kind of go through this here. I kind of gave up on it. And let's go on some check marks and stuff. What this means is, as you go through it, what shape has both pairs of opposite sides congruent? And just put a little X into each one of them that has that. Take a couple of minutes and do that, and we'll go back. Hey, all right. Real quick here, let's just kind of. Here I'm thinking, oh, this is a great idea. Let's go through this whole chart, and then realize there's two on here that we haven't talked about. So let's just talk about it real quick. What has both pairs of opposite sides congruent? All of them. All of them. Both pairs of opposite angles are congruent. All of them. Exactly one pair of opposite sides are congruent. Exactly one pair of opposite sides are parallel. Those are two ones that we're going to talk about tomorrow. Those two are going to be, you guys have all seen them before. You guys know what that's called? That's a kite. Kites have one pair of opposite sides that are congruent. I'm sorry, one pair of opposite angles that are congruent. Kites are also, they have two sets of consecutive sides that are congruent, and the angles that are the same between them are these guys here. The reason being is that when you have, if you look at this as just a triangle, that's an isosceles triangle, isn't it? Isosceles triangles have congruent base angles. So that means that these two angles here and here would be the same. So then here you have another isosceles triangle, which means these two angles are the same. So when you add two things together that are the same, you get two equal angles. That's why those two angles wind up being the same. We'll do that one tomorrow. It's super easy. And then the other one is the one that has one set of parallel sides. The one that has one set of parallel sides is a trapezoid. Okay? And we'll do that one tomorrow as well. And there's two types of trapezoids. You've got a basic trapezoid and the one you probably all have seen. Remember what that one's called? Very good. That one's the isosceles trapezoid. Those are the three shapes that we have left to talk about. There's a couple of properties thrown into them. Nothing too crazy. But we'll look at all that tomorrow. There's a formula for. Remember, guys, we did mid segments before. We do mid segments with that one. We do a little bit of angle stuff. These guys are all perpendicular. It's not too complex for, and I don't like to go. What's that? Oh yeah. These guys will be base angles are the same here. These guys are the same. As you know, a lot of times on Fridays we usually use quizzes and stuff like that. I figured if I throw this one to a Friday because obviously we're not going to quiz after 2 days. That's just, I mean, as you know, I'm a bit of a jerk, but I'm not that big of a jerk. No, sometimes you might say that, but whatever.
So for one pair of opposite sides, because it's opposite sides, because a rhombus has all four sides and the square has all four sides of the same.
Yeah,
Right?
well,
Is that
one.
what you're asking? Opposite sides or opposite sides?
I was thinking that exactly one pair, which means there's only one set.
Oh. Oh, exactly.
And then exactly one pair. Yeah. And then consecutive angles are supplementary. There you go. Which one had diagonals that bisected? No, I was saying that they're all happy. Okay. Rhombus and square. Those were which ones? That was the. You're welcome. Oh, you were talking to me.
What about
Exactly one pair of opposite angles. Yep. Exactly one pair of opposite would be the effects. Yeah. And parallel was exactly one pair of opposite sides parallel. Rhombus, both sets are parallel. Both sets are congruent angles. Yeah, it's
exactly one?
both pair. I know. So. Yeah, always, sometimes, never are parallel. I don't think so. Yeah, there's gonna be 15 questions of it. They're worth double points.
Oh, good, good. Yeah.
I know I'm saying always, sometimes, never. All right, so here's the idea. What we're going to be able to do here is a little bit of algebra today. That's kind of what we've been looking at all along. For what value of x is ABCD going to be a rhombus? Now, when you get to these parts here like this, it's a matter of what are you looking for, what are you working with, and what property of the rhombus are you going to use to solve for x. When you look at that diagram, are those angles across from one another so we can set them equal to each other? Are those angles next to each other on the same line where we'd have to put them supplementary? Or are those angles created by a diagonal? They're created by a diagonal. Okay? So when you have a rhombus, what do the diagonals do to the angles? Bisect them. When you bisect them, those two angles then are equal. Okay? So even if you guessed, you're either going to be equal or you're going to be supplementary. So if you think about it, you got a 50-50 shot of getting it correct.
But if I look at the size of those angles, they look about the same size. So if I had to guess by
Are you using an educated guess, a hypothesis? Oh, stop yourself. Stop. So you get 6x minus 2 has to equal, so yeah, 4x plus 8. Again, you're back to the algebra we've been working on for the past few minutes. It's not over the top crazy, except for that number 16, which was just oops on that one. Okay. So let's see, subtract 4x, add 2, we get 2x is 10, I believe. On the value of x, it makes it work. It doesn't say to double check it, but it only takes a second. What's 6 times 5? Subtract 2, you get 28. 4 times 5 is? Add 8, you get? It's pretty, my singing is angelic. All right, same idea. For what value of y creates it to be a rectangle? What would you do? Why? What do you know about diagonals in a rectangle? Well, let's start at the beginning. Diagonals in a parallelogram do what to each other?
Yeah.
They bisect each other. Very good. So if diagonals bisect each other, all right, so in a rectangle, what makes a rectangle, something about the diagonals, that the diagonals are congruent. So when you bisect two things that are the same, that makes all four of those chunks the same. And that's when the property comes into play. So again, the guess of, set them equal to each other, it's not wrong, but it's the why. So you get your 5y. And lo and behold, it maths rather quickly. Subtract the 5y, add 5, we get, what is that, 8? 2y, I believe? Or 4. 23 and 23. One of the things that you might see with something like this is that it would say, hey, find the value of y, and then what is df? If it asks, it might say, what is df then at the end after doing all that work? Well, if you figure out what the value of y is, you substitute in. 7 times 4 is 28. Subtract the 5, you get 23. That means that part's 23 and that part's 23. Like you said, Josh, it is good. Okay. So the mathing isn't going to be tough. It's the reading about what the mathing is asking you to do is what usually messes students up with these things. I had that many more. Oops. For what value of x is parallelogram ABCD a square? Sir? Well, is that value of x talking about segments, or is that value of x talking about an angle? It's about an angle. Why do you think that it's talking about an angle? Or the fact that it has a degree symbol? Everybody see that? Yeah, good. You're overthinking it. You're overthinking it. This, what's happening here is that this is the dead giveaway that it's talking about an angle. Diagonals inside of a square intersect to form what kind of an angle? Yeah, 90 degrees. Remember, these guys' diagonals are perpendicular to each other inside of a square. So that means that 6x plus 6 has to equal 90. That's where that's coming from. The idea that you recognize that it's got the degree symbol, and you work out of that. So you have another, two-step equation. Subtract the 6. How much was the Joshua? It's using those properties in order to help you get through it. Remember, excuse me, squares and rhombi, are the ones that have the diagonals that are perpendicular. Everything else you kind of have to roll through. Not too terrible. I didn't think this section is actually a little bit easier than what the stuff we've been doing the past few days. Let's see. I actually made everybody use this sheet, but this textbook was designed for last context.
There.
All right, so on this one here, we'll do 1 through 10, and then yeah, 13 through 18. Okay. Should be able to knock that out here for you. Okay. Please and thank you. On number 18, do you guys know what it means by checking to see if something is square? In order to check to see if something is square, it means it has to form a right angle. That's what that means. That's how we check to see if something is square. Try to see if you can figure that out.